So here's something crazy. It's an everyday baking item that could help to calm bees. A research student at UCSD has been doing a study using our TechBee smoker. The data is looking really promising. I've got the ingredients right here in my kitchen cabinet. Let me know in the comments below if you think you see it. Let's talk to her now about how something so ordinary could make such a big difference on calming bees.
I'm Emily Littman. I'm working in James Nie's labs at UC San Diego. So I'm studying honeybee aggression. So I went to UCSD for my undergrad in microbiology and kind of pivoted towards ecology, behavior, evolution. My work primarily focuses on honeybee aggression and ways to mitigate aggression, looking at heatballing, which is a defensive technique used by honeybees and some other different types of bees as well. So heatballing is this defensive behavior that I kind of like to describe as bees finding a predator at the entrance of a hive, and bees
Mhm.
will swarm it and form a ball around it. So essentially what they're doing is heating up and kind of shaking and creating this like CO2 in the ball that is killing a
Mm,
predator. So we don't know
interesting.
too much about mechanisms behind it. So that's kind of more of my focus.
So like the Asian hornet, way too big for
Mhm.
a bee to kill by itself, but grouping up on it and
Yeah,
adding CO2 knocks it out first, maybe, and then it's able to sting it to death or something like that. Okay, cool.
exactly. So it's all
Yeah.
like colony numbers are kind of coming into play. So one bee can't really kill a wasp, for example, but when you have
Yeah.
50 plus, sometimes hundreds of bees, that can really do the job.
You're working on how to calm bees, how to work with bee aggression,
Yeah.
and I'm working on, how to calm bees with a device. You're coming at it more from a scientific perspective. I'm coming at it from more of a product or more of a device perspective to have you involved to figure out like, are we actually calming bees or are we just moving them from one place to another?
So the technique you guys are using is really helpful because we're looking at like the top of a hive, right? So seeing if bees will go back inside a hive, which is one of the things that
Mm,
smokers, which is really common for beekeepers to use. That's the main technique we use. So that's a really good measure. But then with the stuff I've been working on, I've been looking at mainly outside of the hive aggression. So if
mm.
they sting and how we can mitigate that. So combined, it's really
Okay.
nice.
How do you actually tell if a bee is going to sting or not?
So my primary kind of technique is using these black suede flags. So it's a black fabric and bees can sting it pretty easily. So the goal is we have these flags kind of hanging and we're looking at how many times do the bees sting. There's these bees called guard bees that are the defenders of the hive essentially. So when there's a predator in front of the hive, these bees are kind of the first to signal, oh, there's a threat, let's do something about it. So
Mhm.
these bees, as well as some foragers, will also sting. But by looking at the st number of stings on this black flag, we have a really good way to replicate. Oh, so this odorant is decreasing the number of stings. This odorant is increasing them. No
Mhm.
odorant is doing this, and vice versa.
That was an interesting finding too. Some of the odorants that you tried actually increased the amount of stings, right? And you end up
Exactly.
using dark colors mainly because bees are more aggressive with darker colors. At least
Yeah.
that's the theory, right?
So they kind of
Yeah.
view darker colors as a threat, is kind of the theory behind that,
Mhm.
versus light colors, which is why beekeepers wear white bee suits, for example.
Right. Yeah. So the basic process then is, in I'm paraphrasing here, but you're going up to the entrance, you're irritating them with a feather. You actually put an odorant on them, right, of some form, using
Mhm.
different pods and things like that. And then you have the suede there and see how many of the bees actually attack the suede as considering that to be the attacker, right?
Yeah, so we're using your smoker as a kind of substitute for a regular smoker with actual smoke. So what we're
Mhm.
doing is we use that feather, go across the hive entrance a couple times, and then we spray using your smoker, and then we
Mhm.
kind of repeat that every 30 seconds, just as we would like a normal smoker, kind of keep smoking the hive to kind of simulate those same conditions.
I should also say, before we go too much further, UCSD does not endorse any products of any kind, right? And so they're not endorsing my product. And I just want to make that very clear that this is just a relationship where we've been able to work together to be able to figure out a problem, not something where the actual university is in any way endorsing my product. So I just want to make sure that that's very clear to anybody that's watching this. Why don't you tell us a little bit about what you found? Because again, that was a bit of a shocker to me. I would have never expected this.
We found that the base was actually making the bees more aggressive, that
Hmm.
you were using. So through our trials, we tested 5 different odorants, one of which was the base. We found that 2 were actually decreasing honeybee aggression, whereas 2 were increasing it. And then the base was actually kind of a middle ground. So the base was causing more stings than you would expect.
So that's been very useful to us. We've ended up changing the base to another base, and we'll end up testing that as well to make sure that the base itself isn't impacting the results. Because the odorants, it's cool to see that the odorants they're actually calming the bees. But if we're using a base that is actually irritating the bees to start with, then we're starting at a baseline,
Exactly,
that's
that's
higher than we
higher.
should. I think that's really going to be amazing when we test these other bases to make sure that all of the components are calming the bees. That was really useful. You kind of found a different substance that I had ever thought of. I never even thought about testing this. What was it that you ended up discovering, and then more importantly, how did you even figure out that it would potentially calm bees?
So the main odorant I'm using for my trials is Vanillin. Some native beekeepers in Mexico actually were using that, and that's what Dr. Nye found throughout his work throughout his career. So we're kind of trying that in a more like controlled environment in the lab and in the field. So that's been really cool. We've been finding some results. They're preliminary still so far, so I'm still working on more and hopefully I'll get more of those out in the next couple months.
And so, what made you decide to start researching aggression?
Yeah, so I kind of fell into the world of bees, and I'm really glad I did. But I started off in high school. I did this summer project. It was a little research fellowship that I got for high school students and ended up studying bees, native bees in Utah for a summer, and that was fantastic. And I got to UCSD's campus, and then there was a bee lab, and I was like, oh, let me apply. This looks really interesting. And then I fell into that my first year, and I've been working on it ever since. So I'm doing my master's right now in the lab. So it's been a little over 4 years now, which is absolutely crazy. And so in terms of aggression, I first started working on pesticides in the lab. So I was working on a pesticide called thiamethoxam. And I pivoted after my graduate student I was working with graduated and started working on the aggression. It sounded really interesting. It was a project Dr. and I had been wanting to work on for a while, and it was something I could really make my own with it. So
Mhm.
throughout the years, we've pivoted. We've done, I think we're on like 5 different types of experiments now with it. It's great because there's also the environmental factors that kind of come with it. So at first I
Mhm.
started like, oh, bees, aggression, which is super interesting, but we're using smokers out in the field. What if you drop a smoker, which people have done before, and then there's wildfires and all that
Mhm.
kind of comes into play.
So why don't you talk a little bit about also those other experiments that you've got? Because I love that little arena that you've got.
Are you not entertained?
How does that work?
Yeah, so our arena experiments they're kind of twofold. So we're using this alarm pheromone chemical called isopentyl acetate, which is basically the manufactured form of alarm pheromone. And in these trials, we have a giant arena, and inside we'll put a bee or 2 bees, depending on the experiment. And we have one of those ostrich feathers inside, kind of rotating in a circle. And we're
Mhm.
looking at aggressive behaviors. So we're looking at with this added alarm pheromone, are the bees more likely to sting, bite? Are they lunging
Mhm.
at the feather? If we use other scents, if we use a blank, which is basically no odorant, so we're using like either water or a different base, what are their behaviors? Or if we're using vanillin, what are their behaviors? Or same with
Mhm.
some of your odorants we tried, and we were looking at their different behaviors and if we can find significance between which ones calm them, which ones make them more aggressive.
Mhm.
Another interesting way that I saw that you were measuring is using something like a FLIR camera, infrared camera, in order to see if the bees heat up. Basically, if the bees heat up, then it means that they're getting aggravated, which was kind of a cool insight for me. I didn't realize this, but obviously, this is something that's been done in science for quite a while. It's definitely something I'm going to use to test out different scents in the future.
Do you see a big reaction in this arena of between
Yeah.
the different odorants?
Yeah, exactly. So it kind of depends on which trial we're doing. I've done trials with 7 bees at a time. So we have some bees from one hive, and we're looking at their aggressiveness towards bees from a different hive, and all
Oh.
different factors like that. Bees versus a yellow jacket, bees versus a feather, that kind of thing. And we have seen some promising results where bees, especially bees that have more other bees from the same hive, in an arena can be more aggressive and show more aggressive behaviors. We've also found it kind of depends on the season. So during winter, it's kind of a little, there's less aggression sometimes versus spring and summer. The bees are more active naturally. So sometimes we're seeing more aggression. So when we're out in the field, we see some differences based on like weather and that thing kind of stuff. So we have to control for that. In the lab setting, it's a little different. We have a lot of different controls. So we control the room temperature. We control everything is super clean. So they're not getting scents from anything else passed on to them and that kind of thing.
What did you find, if anything funny or unexpected that you had happen when you were doing all the testing?
Working with the bees, especially out in the field, it's always a fun experience. Throughout the years, it's been really fun because I've developed a bee allergy. It's okay.
Oh no.
So that's been super fun.
Always have an EpiPen nearby, I guess.
Yeah, that's okay. It happens. I think just working out in the field with bees is so much fun because they're so cute, and I love a little drone and a little brood when they're coming out of the comb. It's so adorable.
Thanks for all the research. It's been amazing.
Good. I'm glad it's been helpful. It's been really fun.
I want to thank Emily, Dr. Nieh, and everyone at the UCSD Bee Lab. It's been a lot of fun figuring out what odorants affect bee aggression, and I hope to see a lot more of this research in the future.
As a side note, if you're part of a university bee lab and you would like to do this kind of research with me, it would be amazing because I'm really trying to figure out different types of essential oils that we can use in the smoker to be able to control for varroa mite, to be able to control bee aggression, and then also to control for small hive beetle. If you have research students that are looking for different theses, if you have different types of things that you want to experiment with, just let me know in the comments below and we'll get in contact.
In the meantime, make sure to like and subscribe to the channel and also to sign up for the very important Beekeeper Club. It's 100% free and easy to join.